So guys, before we get started, let's reset our calculator. So it's second plus 712, and it'll say RAM cleared. Then you're gonna go to your mode button, and we need to make sure that you're back in degrees. So go down to like the second or third line, and you wanna make sure that you're in degrees. This would also be the time when you would want to switch your screen view from full for your graph to graph table, so that when you actually put something in your y equals key, you're gonna see the graph and the table at the same time. Remember, to toggle over to that, you need to hit second graph, and I'll take you over to your table so you can go up and down, okay? Okay, so we're gonna start on our new set of questions for week 2. The question number 8 is towards the front, so they feel like this is one of the more simple problems that you'll be able to get. So let's go ahead and let's start with this one. So I'm gonna read it to you first, and then I'll tell you what's important in it, okay? So the larger of two numbers exceeds 3 times the smaller number by 6. The sum of 3 times the larger number and twice the smaller number is 62. Which equation correctly identifies x as the smaller number? Okay, so first of all, let's just read that first line. So the larger of two numbers exceeds 3 times the smaller number by 6. So the larger number is 3x plus 6. Okay, that's the larger number. Then it says the sum. What does the sum mean again? We're adding, right? We're adding. So the sum, we're going to add together of 3 times my larger number. So this was the larger number, right? So 3 times my larger number and twice the smaller number is 62. Is your equal sign, okay? Equals 62. Okay, so let's look down here and let's see which one it is. So we've got our 3 out front. This one has a 2, so it can't be that one, right? This one has a -6, so it can't be that. So we've got these 2 options right here. So 3 times the larger number plus 2 times the smaller number is 62. So this would be F, okay? And we will do a couple more example problems so that you can see that in just a minute. Does anybody have any questions about that? There's any little bit of that confused you at all? No? Okay. Let's sweep that, and then let's go to question 29. So question 29 is more towards the end, which means that ACT thinks this is a little bit more difficult problem. I would say that it's really not. It took me a minute to kind of figure out that you could just do slope for this problem. So slope can be called rise over run, right? But it's also called the constant rate of change. So I'm going to read this to you, and you see if you can figure out where that constant rate of change comes in. So it says Steve earns $22,000 his first year. So $22,000 his first year. He is given a raise of the same dollar amount each year, resulting in him earning $34,000 his 4th year. Okay, 4th year. What is the total of Steve's earnings during his first 4 years at the job? So we need to figure out what he earned his 2nd year and his 3rd year, right? And what we're adding each time. So I would do a table for this. So 1, 2, 3, 4, those are his years working. In year 1, they told us he made $22,000. In year 4, he made $34,000. Okay, and so we need to figure out what to do in the middle. I'm going to show you 2 ways to solve this. The first way is using slope, because that's the constant rate of change. It changed by the same dollar amount each year, okay? The second way I'm going to show you is just in your calculator, like if you can kind of think it through how you could just solve it by doing some division and everything, okay? So first of all, if I'm doing the constant rate of change, remember that formula is y2 minus y1 over x2 minus x1. So you guys remember when I said slope never goes away? Does slope ever go away? No, it's here all the time. So anyway, we're going to fill this out by doing this. We start with our ending amount that we're making, 34,000. Okay, minus our starting amount, 22,000. And we'll put that all over the years. So 34,000 was my fourth year, minus my first year was the 22,000. So go ahead and put that in your calculator in a fraction, okay? So to get your fraction, you hit the green button and the one next to it. Once you get your number, tell me what you get.
17 over 11.
Does that look like what? Yeah, fix that, okay? Yeah.
4,000.
4,000, okay? So 4,000. All right. Hey, chatty people, make sure you're paying attention. Okay, so 4,000, right? So that means each year he went up by $4,000. So 22,000 plus 4,000 is 26,000. Okay, 26,000 plus 4,000 is 3,000, or I'm sorry, 30,000. And then adding another 4,000 gets you 34,000. So we went up by the same amount each year. And then what you would do in your calculator is total all of these. So go ahead and total those up. And tell me what you get. Guys, if you're not actually physically using your calculator, you will not get better at it. You have to pick it up and use it every single time, okay? What'd you get?
17,000.
If you added 22,000 plus 26,000 plus 30,000 plus 34,000, what do you get? 112, okay. I'm sorry, I thought I heard 400 something. So 112, okay? Now let me show you the kind of an easier way if you're not sure to use slope. The thing that told me slope, you guys, was same dollar amount each year, right? So if you see that, you got to think of slope. It doesn't say slope anywhere in here, correct? Like you just have to know.
If you're in the building, please report to the main office immediately. Cortland Woodruff to the main office immediately. Thank you.
Okay, so here's another way you could have done this, all right? So let's just say, I'm going to rewrite my table, and I just want to show you just a little something different, okay? So let's say that we had our 1 and our 22,000, and then we had our 4 and our 34,000. You could write your other numbers here, and then to figure out how many times you would need to divide the difference between these numbers, you could do this. So that's 1 year that I'd have to add, right? There's another year I'd have to add something. And there's another time I would have to add something to my original amount. So you could do just in your regular calculator, and I want you to try this, you could do 34,000 minus the 22,000. Okay, hit enter and get your answer. And then how many of these little kind of, I guess, caret marks did I have? 3. So you would divide the difference by 3 and you would get 4,000, okay? So there's 2 different ways you can figure it out, but when you see this same dollar amount each year, you need to think about constant rate of change or slope, okay? Okay. Did everybody recall the slope formula? Or yes? Okay, okay. All right, we're gonna move on to the next 2 problems, okay? Give me 1 second. All right, so now we have questions 22 and 32. So again, kind of later in the test, this is about midway. This is getting towards the end, right? Okay, so question 22 says a manufacturer needs 57 pounds of grapes to make 24 cartons of raisins. Okay. Anytime you see this, it's starting to ask for a proportion, okay? A manufacturer needs 57 pounds of grapes to make 24 cartons of raisins. How many pounds? Pounds is on top, right? So how many pounds, we don't know that, that's our variable, of grapes would the manufacturer need to make 16 cartons of raisins? Okay, so the one thing you have to think of is this. You've got to make sure all your data is lined up correct. So on top, I have pounds of grapes. Are both of those pounds of grapes? So this is 57 pounds of grapes, and then we're trying to figure out how many pounds I need, okay? And then on the bottom, that is raisins, okay? So if I have 57 pounds, I can make 24 pounds of, or cartons of raisins, but I only want 16 cartons of raisins. So you just have to make sure your data is lined up correct, okay? And now there's two different places to solve this. Numeric solver is one. So math, arrow up, enter. That'll get you to your numeric solver. You need a fraction in both boxes, right? So you need a fraction in the top box. So your numeric solver looks like this, guys, when you get there. Okay, so in this top box, you actually do need a fraction. So you'll do your 57 and your 24. In the bottom box, you also need a fraction, so it would be your x and your 16. Remember, in the numeric solver, you have to hit graph, graph slow, or alpha enter to get your answer, okay? What'd you guys get? 38. 38, that's correct, okay. Now, I want to show you one other way, because there really is no reason to go to your numeric solver on a problem like this, because you can just do it in your regular calculator. So I'm going to rewrite this real quick. So, yeah, so 57 over 24 equals x over 16. So when you're doing this in your regular calculator, you can do it all in one line, okay? And you're going to multiply the numbers that are diagonal, and you'll divide by the odd number that's diagonal from your x. I'll say that again, okay? So you're going to, the two numbers that are diagonal from each other, we're going to multiply together. So 57 times 16, and then we divide by the other number that's diagonal from the x, divided by 24. Okay, so numeric solver, make sure you have fractions in each box, graph, graph to get your answer, or regular calculator, we're gonna do the two that are diagonal, we multiply, and then we divide by the number that's left off by itself. Does that make sense? Okay. All right. So guys, real simple proportion, okay? These can be used like if you have a recipe and you're trying to cook for your family, right? And you want to make it bigger or smaller. If you want to, you know that you have a certain amount of potatoes, but your recipe calls for something else, you can actually figure it out by setting up a proportion. This is a skill that we learned like back in the 6th grade, but it applies to so much in math. It really does. It's a great thing. I love this. It's probably actually one of my most fun things about math is the proportions. I love them. You can compare anything. Okay, we're gonna move on to the next one. Okay, so George ate 1/4 of a pie on Monday, 1/3 of a pie on Wednesday, and the final 30 ounces of pie on Friday. How many ounces of pie did George eat on Wednesday? So I would write first what it's saying. So I'm going to show you what I'm reading. So George ate 1/4 of a pie. Okay. Then he ate 1/3 of a pie. So I'm adding plus 1/3. Okay, and then he ate the final 30 ounces, so plus 30 ounces. Okay, plus 30 ounces on Friday. How many ounces did George eat on Wednesday? Well, the very first step of this, you guys, is we have to get a common denominator. We can't have different numbers there. So what does 4 and 3 both go into? 12, yeah. So we would do 12, so I'm gonna do 12. So 4 goes into 12 3 times, plus 12 again. 3 goes into 12 4 times. So that is 7/12. How many twelfths do I have left over? That's 7/12, right? What's a whole? How many 12s? 12, yeah. So if I have 12 over 12, look, 12 over 12 is a whole. Okay, 12 over 12 is my whole. I have 7/12 between Monday and Wednesday. So I'm going to subtract that, okay? So minus 7/12. So that means I have 5/12 left over, okay? I'm going to take that 30 ounces and I'm going to divide by 5, okay? So 30 divided by 5 is 6. So for each 1/12, okay, so for each 1/12, that is 6 ounces. Okay? So from there, I'm just going to answer my question. So it says, how many ounces of pie did George eat on Wednesday? Well, on Wednesday, he ate 1/3 of a pie, which is really 4/12. So we're going to multiply 6 times 4. So 6 times 4 is 24 ounces that he ate on Wednesday. Okay, so I'm going to go back through the process one more time and just describe it one more time, okay? So as I'm reading, I'm writing my fractions. So George ate 1/4 on Monday, and I'm going to add that to the 1/3 he ate on Wednesday, and add it to the 30 ounces he ate on Friday, okay? He must not like to eat pie on Tuesday and Thursday. He only ate them on Monday, Wednesday, and Friday. I can tell you that pie probably would not have made it through my house past Tuesday because I probably would have eaten it. So the next step is to make sure that we have the same denominator, okay? So 4 and 3 both go into 12. So 4 goes into 12 3 times. So 1/4 is 3/12. 3 goes into 12 4 times, so 4/12 is 1/3. I added those up to see how many 12s he used or ate on Monday and Wednesday. My next step was to subtract the 7/12 from a whole. 12 over 12 is a whole pie. So we subtract the 7/12 and we get 5/12. So then this 5 is what I take and divide by my ounces that are left over to get what each 1/12 equals. Well, for every one, that's 6 ounces. And I know that we're talking about how much he ate on Wednesday. And he ate 4/12 on Wednesday, so 4 times 6 is 24. And your answer for this problem is 24. Do you guys think this is something you need to practice? Yeah. Because you're not going to understand it if you just look at it. It took me a minute just because I don't do the same thing every day, right? Like this isn't a skill that I work on every day with you guys in Algebra 2 or Pre-Cal. So it took me a minute to try to figure it out. But it is something that you guys have all done in the past. So if you just practice, you should be able to be okay with it. Okay, we're gonna switch to the extra practice, which is just right behind. And I'm gonna do one of each of these with you just to make sure you're clear about how to do them. If I can find it, what did I do with it? Okay, hold on, gotta find it. There we go. Okay, so we're gonna do this first problem, okay? So the first one says a length of a rectangle is 4 inches less than twice the width. So I would actually draw myself a rectangle here, you guys. Okay, so I'm gonna draw my rectangle. Remember, a rectangle has 2 short sides, 2 long sides, okay? So the length is what we're calling, we'll call this side the length, okay? So it says the length of a rectangle is 4 inches less than twice the width, okay? So 4 inches less than twice the width, okay? So I would call this W minus 4. Okay. Do you guys all agree with that? Yeah, does anybody disagree? Think it should be anything different? Okay. Okay, so 4 inches less than twice the width, okay? The perimeter of the rectangle is 52. The is 52 is the equal 52, okay? Which equation correctly identifies W as the width of the rectangle? So the width W, okay? All right. So when I'm looking at this, I'm looking at a couple of different ones, okay? So I'm going to mark off the ones that I don't think it is, and I'm going to describe to you. So everybody look at C real quick. Do you see how this says 2W minus 4 plus W? Well, I can't just do one W if I'm doing perimeter, right? You've got to add both sides. So it can't be this one. So let's just get rid of ones it can't be. Cannot be that one, okay? This also said 4 less, right? So do you see how B has a plus in the middle? That can't be it either. So I'm looking at these two options, A and D, okay? They both have the same components, except if you look at A, it has 2W minus 4, and D has W minus 4. So I'm going to read it to you again, okay? And you guys tell me which one you think it is. So the length of a rectangle is 4 inches less than twice the width. Do you think this should have a 2W in front? So 4 inches less than twice the width. Okay? All right, and then the perimeter is 52. So to do the equation, we need 2 times this, right? Because we have 2. So 2W minus 4. Okay, and then I also need 2 times W, because I have 2 of those, right? And then that is going to equal 52. Would everybody agree that that is the correct answer? Okay, I believe that's the correct answer. I'll tell you, when I looked at this earlier, I was thinking this, but the more I read it, it says 4 inches less than twice the width. So 2W minus 4 for each of those lengths, okay? All right, you guys feel pretty good about that? Do you want to try another one of those, or would you like to go on to the next kind of problem? One more of those? Okay. Okay, so a large box weighs 5 pounds more, 5 pounds more than 4 times the weight of the small box. Okay, so that is going to be 4x plus 5. That's the large box, okay? The total weight of 2 large boxes, so we need a 2 out front, and 3 small boxes, so and 3 small boxes is 98, equals 98. Okay, so let's see if we have that one here. So we need a plus, so 2 times 4x plus 5 plus 3x equals 98. So this would be G. Okay. Do you feel a little more confident about that kind of problem? A little bit? Okay. All right, we're going to go to the next page, okay? Hey, I also left at the top what type of problem it is, so that if you need to look up other ones, you can, okay? So if you just go in and look up arithmetic series, sum over time, you should be able to figure those out, okay? How to get extra additional problems if you need them. Also, AI is a great place too for that. A lot of these, that's what I did. I just put in the example problems and then said, AI, make me some more of these, and they did. So you can do that too, okay? Okay, so number 6 on your practice problem says a student does 15 math problems the first day. Okay, so on day 1, he did 15. Okay, she did 15. She increases the number of problems she solves by the same amount each day, same amount. So we're thinking slope, constant rate of change, okay? Solving 27 problems on the 4th day. 27 on the 4th. Okay, so let's do slope because that's the easiest way to do this. So you need a fraction in your calculator. And on top you'll have 27 minus 15 over 4 minus 1. Go ahead and put that in your calculator and tell me what you get.
4.
4. Okay. So then all we're going to do is we're going to fill in those other two, the other two that we don't have, okay? So 2 would have been 15 plus 4, so 19. 3 would have been 19 plus 4, which would have been 23. And then let's add all these up. How many?
84.
84. 84. Good. Hey, for those of you who have me in math, and we do a lot of problems, right? She did 84 problems in 4 days. That's pretty good. So if you're not doing 84 problems in 4 days, you're not really keeping up with our friend here, okay? Need to be practicing, honestly, every day, you guys. If you think about it, we're taking it on the 10th. That literally is only like 5 weeks from now. So you just have to dig in for 5 weeks, okay? And try to make sure that you're like just practicing a little bit each day so that you remember how to do these problems, okay? Let's do one more just to make sure you guys are good. Or you guys feel good about this one? You feel pretty good, or you want to do one more? One more? Yeah, okay. Okay, so a jogger, so I'm going to put this one on this side, okay? A jogger runs 3 miles his first week, okay? He increases his distance by the same amount each week, okay? And he did 4.8 his 4th week. So I'm going to do his first week was 3, his 4th week was 4.8. Okay, so we're going to find the slope using these numbers. All right, remember our y's go on top. So let me move this down. Okay, so 4.8 minus 3 over 4 minus 1. And just to make sure that you have things lined up right, you need to double check this step right here. So 4.8 goes with 4, and they should be right over top of each other. If you have these transposed, you will get the wrong answer every time. They have to be the ones that belong together over top of each other, okay? And then same thing with our x coordinates. These are x's. Okay, so where I have my 1, I had my 3 on top. Okay, so just make sure you got them all lined up, and then once you put them in your calculator, tell me what you get.
18.6. Oh, for the answer, just
The answer to just my slope part.
I got 0.
0.6, right? So 0.6. Okay, you added up the whole thing over there. I know you're working ahead of me. Okay, so 0.6 is our slope, okay? So look, in the second, what are we talking about here? Second week, we're gonna add 0.6 to 3, so 3.6. Then the third week, we're gonna add 0.6 again, so 4.2. And just to double check yourself that you got the right slope, this should be 0.6, okay? And it is 0.6, so now add them all up. And somebody already told me the answer. What is it over there?
15.6.
15.6, good job. All right, we good, you guys? Okay, Kirsten, will you just tap her real quick for me? Okay, let's go on to the next couple of examples. We're almost done, you guys. Okay. My favorite kind of problem. All right, these are all proportions, okay? So a recipe requires 42 ounces, whoops, there we go, 42 ounces to make 18 cupcakes. How many ounces of flour? We don't know that, that's what we're trying to find. Do you need to make 12 cupcakes? So just double check that on the bottom we have cupcakes. 18 cupcakes, 12 cupcakes. On top is our flour that we need. This can be done in the numeric solver, okay? Top box fraction, bottom box fraction, I would go ahead and use that. 28? Good. Awesome. Let's do one more just because these are super quick, okay? All right, a car uses 8 gallons of gas to travel 220 miles. How many gallons? So that's my question. That's where my variable goes. Does the car need to go 165 miles? So look, on top is my gallons, 8 gallons, and then I don't know how many gallons, but that's why my variable's there. On the bottom, miles traveled. So you can do this in your numeric solver, or 8 times 165 divided by 220. Okay, and what'd y'all say? 6? 6? Good. Okay. I would love it if the ACT was all that, because then we would all do pretty well. All right, we're going to go on to the last type, and then we'll be finished, okay? Okay, so this is back to those fractions, okay? So write your statement first, what you're adding together, and then convert the fractions to have the same denominator. So Tom spent 1/5, so 1/5 of his budget on gas, 1/4 of his budget on groceries, okay? And then the final $110 on entertainment. Okay, how much money did Tom spend on his groceries? So the first thing you want to do is get a common denominator. What do you guys think that common denominator is? 20, yeah. So we'll do 20. Let's switch. So 20, so 5 goes into 20 4 times, plus 4 goes into 20 5 times, so that's 9 20s, okay, 9 20ths or whatever. What is a whole 20 over 20, correct? Okay, so then we're going to do 20 over 20 minus 9 over 20, and that gets you 11 left over, okay? So we're going to take this 110 and we're going to divide it by 11, okay? So 110 divided by 11 equals 10. So for every 1/20th, it's 10, okay? So it's asking, how much did he spend on groceries? Well, groceries was the 1/4 or the 5/20ths. So we're gonna do 5 times 10. And he spent $50 on his groceries. Okay, $50 on his groceries. All right, sound good? You guys want to do one more? Yeah? Okay. So a tank was filled to 1/6 of its capacity in the morning. So 1/6. And 1/3 of its capacity in the afternoon. If 24 gallons are needed to fill the remaining part of the tank, so plus 24 gallons, okay. What is the total capacity of the tank in gallons, okay? So let's go ahead and let's convert these. What would your common denominator be here, you guys? Actually, you could do 6. I did 12 earlier. I like 12 because that's what I used, but now that we're looking at it, you could use 6, right? So we've got 1/6 if we're keeping 6, okay, plus 3 goes into 6 2 times, correct? So that's 3/6. What is 3/6 if I were to reduce that? 1/2, right? So, or 1/2, because that's pretty important actually for this problem, okay? So he had 24 gallons. That was the remaining space of the tank. But if this first part is 1/2, what is the total capacity of this tank? 48, right? 24 times 2. So 24 times 2 is 48. Okay, so look, 24 gallons was half, right? This is 1/2, because this is 1/2 of my tank. So if that's 1/2, all I have to do to find the other is just multiply it by 2. Okay, 24 times 2 is 48. Okay, all right, you guys. Does anybody have any questions? Did you get it? Okay, good. It actually, after you start doing a couple and you start to really get it, you're like, I can do these. You guys can do all of these, okay? So you have 3 problems from last week. We have the 4 problems from this week. That's 7. If you practice those 7, that's 7 you might get right. You know what I mean? So let's spend some time practicing. It's on you guys, okay? Like, I can come up here and give you all the information, break it down and show you how to do it, but unless you actually practice it, you're not going to get it, okay? So you guys practice because you need the good ACT score. We need it for our school report card, but you guys need it because you're going on after this, right? You're going to leave Clay Chalkville High School behind, and the rest of us are going to be stuck here doing the same thing we've been doing forever, right? But you guys, your future is ahead of you, so please practice and try to get the best score that you can, okay? All right, hey, thanks for coming again, okay? All right.